Write down this. Write this first. So, how they react, the very reactive metals, they react with the water to form hydroxide, metal hydroxide. So, how it forms a metal oxide? First, metal plus water. First, it forms metal oxide plus the hydrogen. Okay, this metal oxide, one second. Metal oxide plus water, again they form metal hydroxide. Yeah, what you were asking? Yeah, but in these metals, it will be very much more. Okay, even here it catches fire. What happens here is, it's see, potassium and sodium, when it combines with the water, it will form metal of hydroxide, metal hydroxide. OH is hydroxide group. Plus the hydrogen gas plus heat energy is evolved. It is exothermic reaction. So this heat is so much more that it hydrogen will start burning. Because of that, metal gets burned. Okay. So what happens is, and here also what happens if you observe, the very reactive metals, they form hydroxide. Whereas whereas aluminum and iron, they are not so reactive, right? They form just the oxide. Next it will come. I'll show that difference also is there when the reaction is there. That is only with oxygen, I think. Huh? Here with the water. Not all. With the water, potassium, sodium, calcium, all this, they become hydroxide. Whereas aluminum and iron, they form only oxide. In the water, I'll write first. Write this. Huh. Okay. Okay. First thing, with the water, first potassium and sodium. Potassium and sodium are most reactive metals. When they combine with the water, what happens? Just you put the potassium or sodium in the water, it starts reacting and catches fire. Okay. It is so much vigorously reactive in nature. So they react with the cold water also. No need the water to be hot. If it is just the cold water itself, it will react. And it forms potassium hydroxide plus the hydrogen gas plus heat energy. So this is an exothermic energy. It produces enormous amount of heat. That heat is so much that hydrogen will start burning. Because of that, there is a fire. It catches fire. Okay. With sodium also, same things happen. And how it is from hydroxide? First, metal plus water, you will get metal oxide plus the hydrogen gas. That metal oxide form will react with the remaining water to form metal hydroxide. Okay.
Ma'am, it should be metal plus oxide, no, ma'am. Oxygen.
No, oxide. Write down. Just calcium reacts with water. With water. Reacts with water and it is less violent. It is less violent. That means they react with the water, but it reacts slowly. And it is an exothermic reaction, but it is not so much exothermic that it can, hydrogen can catch fire. Okay. Calcium reacts with the cold water, but it reacts very slowly. It reacts and it is less violent. It is less violent means it is an exothermic reaction, but it is not so much that it can catch the fire. That is, hydrogen produced will not catch the fire. Okay. The heat evolved is not sufficient for the hydrogen to catch fire. And tell me, is this correct what I've written? Is this correct what I've written? Correct? CaOH twice, correct. Why it is like this? What is calcium valency? Hydroxide. So, one calcium reacts with two hydroxide group. So, CaOH twice. Okay. Now, this plus the hydrogen gases evolved. Here, hydrogen gas do not catch fire because even though it is exothermic, it is not so much heat is produced so that it can catch fire. Okay. And another thing, calcium, what happens to that hydrogen bubble? See, when calcium reacts with the water, you will get calcium hydroxide plus the hydrogen gas. See, these hydrogen gas bubbles will stick to the calcium hydroxide, that metal. Okay. So, because of that, it will float in the water. Okay, it start floating in the water. Again, I repeat, see, calcium, when you put that in the water, slowly it reacts with the water, it forms calcium hydroxide plus hydrogen gas will be released. But even though it is exothermic, it will not catch fire. Hydrogen gas will not catch fire because it is the heat is not sufficient for that to catch fire. Okay. But instead, what happens to hydrogen gases? They stick to this calcium hydroxide. Okay, they stick to calcium hydroxide. So they form the bubbles on that. Because of that will float in the water. Okay, so when you put calcium in the water, it floats because of this reason. Because hydrogen gas will stick to the calcium hydroxide. When it sticks to the calcium hydroxide, its volume increases and density decreases. If anything, when it will float, when its density is less than the water, it will float correctly in the water, right? So since it sticks to the bubbles, hydrogen gas bubble sticks to the metal, what happens? Its density decreases, so it floats in the water. Even with the magnesium, the same thing happens. So those questions they ask why it's what happens to the calcium when you put it in the water or why it floats, write the equation, all these questions they ask. Okay. Calcium starts floating because the bubbles of hydrogen, because the bubbles of hydrogen gas formed stick to the metal, stick to the surface of metal. Even with the magnesium, same thing. So magnesium, what happens? Write down this magnesium, but the magnesium do not react with cold water. They do not react with cold water, but reacts with hot water. It reacts with hot. Okay. So magnesium also same thing. Magnesium plus water, you will get magnesium hydroxide. Okay, plus the hydrogen gas. And even magnesium starts floating because the bubbles will stick to that and it will float. If you want, you can write here only calcium and magnesium. Both the same things. Okay. Aluminium, zinc. Okay. Aluminium, zinc, and iron do not react with cold or hot water, but react with steam. But they react with steam. Okay. But they react with steam. And what happens here? Aluminium plus hydrogen. You will get Al2O3 plus the hydrogen gas is released. You want to balance. And if you observe here, aluminum, zinc, and iron, they don't react even with the cold or hot water, but they react only with the steam. Okay. And also, here you are not getting hydroxide, you are getting oxide. Aluminum oxide plus hydrogen, iron oxide plus hydrogen. You don't get hydroxide here. So, like how the reactive metals they reduce, keep on reducing, how they react, it will change. Okay. And what about copper, lead, silver, and gold? They don't react at all. Even with the steam, they don't react. In silver also, silver will not react with oxygen, water, nothing, but only with sulfur it reacts. Whatever that one thin layer, especially what we use the utensils, right, in the puja and all, we use silver plates and all. If you leave it for expose it for a long time, what happens? A thin layer black coating will be formed. No, that is not oxide layer, it is sulfide layer. Silver sulfide is formed. It only reacts with sulfur, not with anything. Okay. Right, metals such as lead, copper, silver, and gold do not react with water at all. Even with the steam, they don't react. Okay. See here also, if you see, few will not react with normal temperature. They react only with high temperature. That's what it happens in chemistry. Even the temperature, what is the catalyst you use, so what is the pressure, like that, so many parameters will be there. Okay. And in what concentration, so many things will be there. It will change. So here each metal it reacts in a different. First it's with cold, then hot water, then the steam. Then these metals they don't react at all. And here if you observe iron and aluminum, they don't form hydroxide group. They form only oxides. Whereas earlier and all what we studied, they formed the hydroxide. That change. All those things you should know. Okay. What happens to copper, silver, gold, and lead? They don't react with the water. How metal reacts with acids. So metal plus dilute acid, salt plus hydrogen. Okay. Magnesium chloride plus hydrogen. So what we observe here, metal with dilute acids, you will get salt plus hydrogen. Okay. It is we get salt plus hydrogen. Why we get salt? Salt because metal is basic in nature. Na? So dilute acid, you will get salt plus hydrogen gas. Okay.
And just all the salts taste like normal salt.
Hmm.
All the salts taste like normal salt.
No. Yeah. So and here also how fast they react depends on its reactivity. Same sodium, potassium, they react very fast. Then comes calcium, magnesium. Then zinc and all reacts, but it reacts slowly. It happens like that. And here also silver, gold, and all they don't react. Written? Next. Write this metal reaction other metal salts. With other metal salts. So metal A, write down this plus salt solution of B. So what you will get? Salt solution of A plus metal B. Okay, example. One metal iron plus copper sulfate will give you ferrous sulfate plus the copper. So this is one example what we can do. What type of reaction I'm writing here? It's a displacement reaction. Metal reaction with other metal salts, that is other with metal compounds. If it reacts, what happens? It will, one will be displacing the other. That is, iron will displace the copper here. So you will get iron sulfate plus the copper. Listen here, what you are discussing. Okay, here it is a displacement reaction. So this reaction happens. Why? Because iron is more reactive than the copper. We studied in the correct reactivity series. If you see, iron is more reactive than copper. That is why here there is a reaction. Okay. Now write what reaction you will get here.
No reaction.
Everyone write. Don't tell. Just write. Well, just check. Right? Both of you. What is the reaction you are getting here? Right? I'll come and check. Better? You also? Okay. Then what would you? You? Whatever you write. There no reaction comes because silver is less reactive than copper. So if you put silver in the copper sulfate solution, nothing happens, no reaction. Okay. Those things they will ask in exam. Clear, no? So this is no reaction. So how metal reacts with other metal salts? When a metal combined with another metal solution, what happens? You will get a salt solution of metal A here plus the metal B. So that is, it's a displacement reaction what we get. But this happens only when a metal is more reactive than the metal which is there in salt solution. Otherwise, there is no reaction. Clear? Otherwise, there is no reaction. Okay. So, Fe plus copper sulfate, you will get FeSO4 plus copper. You have the activity here in your book regarding this. So, what does it say? Copper sulfate solution, it is blue color. Okay, it is a blue color, whereas ferrous sulfate, it is pale green in color. The solution is pale green in color. So what they did is they took a beaker, okay, or a test tube here, and this contains copper sulfate solution CuSO4. Now they will dip an iron nail in this. So what happens here? Iron nail. When you dip that, after some time, there is a reaction in this. There is a chemical reaction. okay, there is a chemical reaction, you will get ferrous sulfate solution and copper is deposited on the iron nail. Here copper is deposited. Okay, again I repeat, see, when you put a in the copper sulfate solution, a nail is dipped. What is the reaction? So you will get ferrous sulfate plus the copper. Earlier, copper sulfate is blue in color. The solution is blue in color. Okay. After the reaction, what happens? It becomes pale green in color. Pale green. Pale green in color. And what happens to copper there? Copper is deposited on the nail. That copper color is reddish brown. The nail color will become reddish brown there. So regarding this activity also they will ask questions. Understood? Copper, all solution color, everything you should know, which is soluble, which is a precipitate, everything you should know. So what is the activity number? Page number 45. Okay, so what happens there? First thing, first iron nail is deposited or put in a copper sulfate solution. So after some time, what happens? We get ferrous sulfate plus copper. How do you know that? Copper sulfate is a blue color solution. When you dip that iron nail in that, we get a pale green color solution, which is ferrous sulfate. And that nail, on the nail, copper is deposited. On the nail, copper is deposited, which is reddish brown in color. So nail will become reddish brown color. Okay. Or if I take this one, copper plus FeSO4, there also no reaction. Because copper is less reactive than iron. That's why no. Okay. So that reactivity series also you should know. So which one reacts, you should know. If it is more reactive, then it displaces. If it is not a more reactive, then it will not displace. There will be no reaction. Okay. This is how the metals will react. Most of the things we have done. Still few things are there. Tomorrow we will do. Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.